Hello guys, welcome back to Inch Electronics. So in today's episode, let's take a look at a professional LED tester. So what's inside this box is a professional version of what you're seeing in front of you. Now this is a DIY version of the same thing. It's an LED tester that is made by me. I made it like 4 or 5 years ago and it's still working fine. And as a person who repairs LED lights, LED bulbs, this is just fine for me. So this thing can actually test anything from a single LED to a string of LEDs that is up to 300 volts. The maximum power that this can deliver is up to 20 watts. So for a normal DIY operations and for not too critical LED servicing and things like that, this is just fine. We don't need a professional grade equipment for that purpose. But there is another group of people who has to deal with a lot of LEDs on a daily basis, the TV service people. Because you see, in my case, I don't repair televisions as often. I can repair, but it's not my daily job. But I do repair LED bulbs, like the normal LED bulbs. So for that kind of purpose, a professional kind of toolkit is not required. I can just go ahead with a DIY version of it. In fact, this thing costs only 150 rupees for me when I built this thing. And the most expensive item in this set is this AC cord. Because I paid around 60 rupees for this one. That was the only thing available at the shop, so I just bought this. This is the only expensive item in this build. Everything else is salvaged from something else, some other parts and bits and pieces. So this professional version is actually 1000 rupees, almost 10 times the cost of this one. So I cannot recommend this one if you're just a beginner with electronics, or just, if you're just repairing a couple of LED bulbs, like 1 or 2 in a month. Then there is no need for purchasing a professional equipment like this one. This is not the sole purpose of it. You can just build one of these by yourself. If you want to see how you can build one of these, just let me know in the comments below. I will make a separate video for that. So today let's talk about the professional equipment. So it comes with a very nice probe. In my case, I just made a probe by making use of the case from an old pen and a copper wire. Can I say like wire? It's not copper wire, it's like a piece of copper that I made it like a probe. So it's a pure DIY version. Still, this thing costs only 1/10 of what this expensive unit costs and can do the same thing. The probes, okay, the probes are actually really good quality. It comes with gold plated contacts, and see that, with very pointy tips. So inside we'll get a manual. It's not a manual, it's just like a leaflet. There is nothing inside, and it's just a box. And in fact, you can buy this online or from a retail store. The price is around 1000 rupees. There will be like plus or minus 100 difference when you're buying from online. And this is the tester itself. You can read the front panel. Yeah, there you go. You can read the description. Input AC 85 to 256, DC 0 volt 30 300 volts, and like you can read all those things if you want. There is nothing on this side. There is a connector for the probes, and it comes with an on-off switch on this side. And let's take a look at the manual. In fact, the manual actually mentions about 3 different models. We can see the CA300L, CA300V, CA300S. They're called as the ordinary, highlight and super bright. Our variant here is the highlight version, CA300V, CA300V. So the specifications for this one is it can test an LED that is up to 18 watts. That's the main difference between these 3 models, the maximum rated output power. The lowest one, the ordinary one, is 12 watts. The highest one is actually 24 watts. The one we have is 18 watts. So the voltage and everything else is same except the output current, of course. And here is the manual. Is it okay? If you want to read that, you can pause the video and read that page. Again, with this side, I think it's a bit difficult in this case because again, it's very small test. But anyway, I'm focusing onto that. If you want to read that, just pause it and read the whole thing. There is nothing on this side, so that is that. So the actual purpose, as I mentioned, you can use this one for testing ordinary LED bulbs, like the common LED light bulbs, the typical ones we use in our homes. But it's not the purpose of it. This is actually designed to test LED panels. So for TV repair people, just like when we are servicing the ordinary LED bulbs, with different manufacturers, and even within the manufacturer, the different wattage LED bulbs, they all have the LED chip voltage at a different forward voltage drop. Sometimes they use 9 volt LEDs inside, sometimes they use 18 volts, sometimes they use 3 volts, so it's very different. And most of the time, with all those normal household applications, I can just get away with one of these. This can easily use to detect, and in fact I have shown how to use this in a couple of my different videos where I repair LED bulbs. So since the primary focus of this video is about this thing, let's plug it in and let me show you how this thing works. And when I plug it in, there's a switch here which I need to turn on, and just notice the voltage. Okay, it's not going immediately up to the full 300 volt. It's like a gradual progression. Let me turn it on. See that it's staying at around 180 volts for now, and from there it actually goes up to the full 300 volts. There you go, it's now fully up to the rated voltage, and it is actually short circuit protected. The output can actually be shorted, which indicates a shorted component while testing. This can also be used to test anything from a single LED to a string of LEDs that are up to 12 volts. So let's grab a handful of LEDs in here.
Let's take this strip, couple of different random LEDs that comes to me. So there's one LED, yeah, let's take this one, these are oleum bulbs. Let's take some random samples from here. These are LEDs that I usually, let's take one infrared. Yeah, like this one. Let's just start, where's the green one? This is the green one. There was the green one. Green, yellow. Yeah, that's a handful.
I think that's enough. Alright, so I have a random selection of LEDs in here. So I'll just show you how to test with this one. So the main purpose of this thing is actually testing LED strips, as I mentioned already. So inside a TV, if you have opened an LED TV, there is actually a string of LED backlight behind the TV. I have one of such strip of lights with me, but I'm not sure whether it's with me. But anyway, I shall include a picture on the screen right now. So to test the voltage drops, to know what is the voltage drop for that particular strip of LED, because same with the LED bulbs, the voltage that is used, the operating voltage for those backlight LEDs are different between different manufacturers, and even it's different between the same manufacturers, different models. So here is the rated voltage. So if I connect the negative to negative and positive to positive, you can see the voltage it shows is 9 volts. So this LED can actually be operated from 9 volts. In fact, it is actually a 12 volt LED strip. I'm not sure whether you can read that or not, but because of this resistance, it's actually you can actually detecting it like that. So not sure whether you have recognized it or not, but it's not a sudden turn on. When I turn the LEDs on, it's not suddenly getting turned on. Just look at the brightness of the LEDs. Okay, have you seen that? It's actually gradually rising up. So that is the specialty of this one. It's not pushing the LEDs, it's not stressing the LEDs so hard like by immediately turning it on. And that's one of the main advantage of this one, which that feature is absent in this one. It's just a steady turn on, but we can actually modify that DIY version to become like a slow starting thing. Next is let's take a look at this one. This is a random string, and I'll just give you a close-up of what's in here. I think it's a sample strip that I ordered online. I ordered, like, this is available in eBay as a strip of LED, like say similar to this one which we have just seen. This is actually available as like a strip, LED strip. That is, this is actually meant to be put onto some kind of device, which I'm not sure. Anyway, for this one, even I don't really know what is the exact voltage of this one. So it's these kind of things that this is actually really helpful. So again, you can see if I turn on one section, it's actually 28.4. The other section again is 27.4. And keep in mind that this is actually 300 volts DC. And just because it's 300 volts DC doesn't make it harmless. It's actually really painful if you get a shock from it. It's not enough to kill you, but it's certainly enough to give you a very bad shock. It's very bad experience. I have actually shocked myself a couple of times when I was working with it. And as I said, you can see if I short circuit this probes, if I short circuit, it just goes to 0. That is the way it can be used to detect a shorted LED bulb. So if I connect it right here, it's the opposite polarity, it's the other way. I have to be really careful because it's 300 volts DC, and there you go, it's 2.2 volts, but the LED is lighting up with, see, it's showing 2.2 volts. So this is a 2.2 volt LED. Let's check this one. This is a random sample again. with these kind of small components I had to be really careful not to get a shock. Again 2.2 volt, the LED is lighting up. Let's see what is the drop of this infrared LED. This is an IR LED right here. It is not visible to my eye, but I hope the camera can pick it up, and yep, you can see that right now. It's actually 1.2 1.4 volt LED. So likewise you can actually use this to test voltage drop of any unknown LED that is up to 300 volts. So here are some LED lights. You can use this to check the forward voltage drop of these type of LEDs, and even this can be used to detect the fault of this LED, like which LED is blown and which is not. Positive comes here. This might be the bad LED in here. This is the negative, so I think that is the faulty LED because everything except that is lighting up. There you go. So this is the bad LED in this one. So that's how you can use this to test LEDs of any length. So likewise, I don't think an extra demonstration is needed with this one, but anyway, since I got it, I'll just try to turn it on. You can see the whole LED bulb is lit, and the voltage drop you can see there is around 68 volts. So you can use this to test a whole LED bulb if needed. So that is it. That is how you can use this equipment for testing LED bulbs and LED backlights. It's the same way. It's the way we tested this thing. It's the way we are going to test the unknown LED strip, which is on the back side of the LED TV. So that is it, guys. That is how you can use one of these for testing random LEDs. So I don't recommend purchasing this one just out of your curiosity. In fact, I do not own this one. I just borrowed it from my friend because for my kind of application where I repair these kind of LED bulbs, it's not necessary to spend 1,000 rupees because I'm hardly making anything out of repairing these kind of bulbs, and I don't want to invest more than what a DIY version can offer into for servicing these kind of small LED bulbs. Because as I said, this can actually test LEDs are up to 20 watts, so LEDs like these can easily be tested with a DIY version. I don't need to spend 1,000 rupees to get an expensive version just to test some household LED bulbs. But you can go ahead and purchase it if you're curious enough, if you want to have a gadget with you always, and if you have just enough money that you can spend on it, just go ahead and buy one. But as I said, I don't recommend if you're just a beginner or a DIY kind of person. So that is it. I just want to give you an introduction to this one. So in the next video, I'll be tearing this one down and we'll see what's inside of it. Thank you for watching. See you with another video.